But this video, we're focusing in on metric and SI systems and learning how to do some of these conversions. Specifically, how do I do these units? And so I'm going to focus a lot in my discussions on the units. All right. And so let's get a little bit of look down here. Look, my nice hole. Terrible. If I hadn't pointed out, you might not have never noticed. Okay. So one thing I recommend if you're taking physics or chemistry or just about anything that's got any kind of measurements, that you come up with this idea of quantity, all right, and then the units, and then the symbol. And I recommend you make one of these for each of them. You might even come up with another thing if you wanted to, which system it's in. So, for instance, distance. All right. And so distance a lot of times has an M for the symbol for it. The symbol for distance is either D or S, depending on what book you're in. All right. So you might, in the units here, M is in for meters. Okay. So you kind of need to learn that. But we have other units for distance. So we might see yards or feet. All right. And so you need to get all those kind of miles. Get all those in your head is distance. Now, what you really want to do is get used to thinking of what is the book going to want? What is the best, or not really best, what is the accepted? There we go. So each field is going to have a different accepted, and sometimes even when we get to doing these, we'll have different accepteds. So when we do pressure, for instance, it might be under PSI. It might be torr. It might be atmosphere. And then everything that would, whoa, camera really doesn't like this hole. I'll fix it. All right. But the symbol for the pressure will usually be a P. Whoa. Disco music. All right. So let's erase it, see if maybe we can fix that thing. All right. Now we're just consistently blurry. All right. So when we see a problem that says something like 25 meters, 30 seconds, 20 degrees. We need to be able to break this information down. And the easiest guide for how to do that is by learning to look at the units. All right, the units guide us through a lot of things. So when this is lowercase m, this is meters. And it's telling me distance. And when I see something that says, has an S, that's seconds. And it's telling me time. And this, oh man, I'm back. Yay. All right. So we were having a discussion about units and their guide. I had to turn off the autofocus. Got that figured out. So if you saw something that said 55L, you need to be able to figure out what it's talking about in a word problem. And so that's one of the things students struggle with the most. So this L is telling me that this is volume. And if I know that volume has the symbol L, it also has the symbol V in an equation, then that's going to save me a lot of trouble later. And so when I see something later that has units of mole, then I know this is an amount of material, and it usually has a symbol of a lowercase n. So when we get to seeing something that is 86 grams, I need to know what kind of system is that? Is that metric? And is it talking about mass? Is it talking about time is, what's it talking about? So this happens to be grams. It's metric for mass. All right. And so you need to come up with a nice list. And you're just going to kind of expand on that as you do your reading. And you'll see a bunch of these, but most of them are pretty straightforward, but you might not be used to seeing them. Now, another thing that you have to be careful about the metric, the whole secret to the metric is it uses this idea of a prefix. All right. And a prefix comes at the beginning. All right. So the base units we see in metric, then meter, liter, gram. All right. We even see seconds. Okay. So a prefix will come before those. And the secret to the metric system is to not try and memorize it like you were taught the English system. So you start off learning the English system, 12 inches equals 1 foot. Right? And you learned a relationship like that and you memorized it. And then you said 3 feet equals 1 yard. And you memorized that. But that's not how the metric system's really set up. The metric system is more based off of set up like the a lot like you would do some basic algebra. So 5 times x, and then we told you x equals 4. And you would put in and replace that x with a 4. And you would directly substitute it. All right, so don't forget, here's my little tear. Then 5 times 4, then you would say, oh, okay, that's 20. All right, and so we're going to replace now, the prefix goes in the front. And so these list of prefixes is pretty straightforward. We go through, come over here, and here's my list. And you'll have this table. It won't be exactly this one. It'll be a little more condensed. All right. It'll have all the same information. But this table is really helpful. And I'm going to just make it a little smaller over here. So you should be able to see it over here. There we go. All right. So, but the way you read this table is actually pretty straightforward. And you could write 1 milligram is so many grams, 10 to the minus 3 grams. You would also be correct to write 10 to the minus 3 grams equal 1 milligram. Okay, both of those are the same, obviously, right? But what I'm going to recommend is you get in the habit of doing this top one, because you're going to write it a lot, and that seeing it over and over, that repetitiveness, it gives you a sense of familiarity. Familiarity. That's a mouthful, man. All right. So it looks like something you've seen before. Now, you probably will have some of you out there saying, hey, but I know 1,000 milligrams is equal to 1 gram. And this is true. This is, if you were taught this way, you were taught the same way you were taught the English system. And so at some point you memorized this. All right. And it's saying the same thing. This, remember, 10 to the minus 3 is the same as 1 over 10 to the third, which is the same as 1 over 1,000. All right. So 1 over 1,000, if I multiply both sets by 1,000, I'd get the same expression. Now, the problem with this system, I'm not going to tell you you can't do it, but I see time and time again students tell me, oh, but I know that system. And then they put the 1,000 on the other side. And here's the problem with that, because 1,000 grams equals 1 kilogram. And the problem they run into here is, which side does the 1,000 go on? Does it go with the grams, or does it go with the milligrams, or does it go with the kilograms? And they get it confused. And it really only takes a couple of times of getting it backwards, and then they really start down the rabbit hole of putting it wrong every time. Now, if you're going to do it this way, the big number goes with the smaller unit. So milligrams is smaller than grams, so the big number goes there. Just like 4 quarters equals $1. $1 is bigger, so it has the smaller number. All right. So that's how you handle that system. But this direct substitution, this is the way to do it. Now, I had learned it the other way. I learned it in 6th grade. I learned it in 7th grade. I learned it again in 8th grade. 9th grade, I had a break. 10th grade, learned it again. 12th grade, we took chemistry. I memorized all this stuff again. Graduate school, anytime I needed it, memorized it again. All this way through until I got, all the way up to my 2nd year teaching. And I had a young lady from a different class came up to me with a group of students, and they were asking me some of these dimensional analysis problems, struggling with it the same way many of you will. All right. And so she asked me how to do this problem, and I wrote down, 100 centigrams equals 1 gram or something like that. And she said, "Why are you doing it that way?" And I remember it distinctly because it was Northern California. And she goes, "Like, why are you doing it that way?" And I was like, "Oh, don't hit her," right? But then I stopped and listened to what she was saying. She said, "Just write 1 centigram, and a C is 10 to the minus 2 grams." And I said, "Okay." And I stopped and I listened. She was right. I went back and I thought on it. I said, "Man, I've wasted so much time memorizing this stuff. And I must have memorized this stupid prefix table over here. I mean, I've memorized this thing up and down. The great mighty King Henry did something I don't know. And man, I've already forgotten how to memorize it." We don't want to memorize it. We want it to be a nice skill that we use the same way every time. So let's do Terra. All right. So it says Terra, and it says it's the symbol T, and it's 10 to the 12. All right. So if I have a terabyte on my computer, it's got roughly 1,000 gigabytes, roughly 1,000 megabytes. Oh man, we learned the same way. I'll explain all that in a minute, but let's see. If I want to do a teraliter, it will look like this: a T and a capital L. All right. Oh, no, I've got something that's 27 teraliters. I have no idea what to do with that. Well, what I'm going to write is my conversion factor is 1 TL. All right. Capital T. There we go. And I'm going to replace this T. This T is 10 to the 12. And so the 1 is still going to be here. We just usually don't write it. And I'm going to have 10 to the 12. And then this L just gets carried over here. So 1 teraliter is 10 to the 12 liters. Right? All I did was directly substitute in off of that table. I took in that 10 to the 12 and brought it down. So now if I wanted to do this dimensional analysis, 27 teraliters, remember this is over 1, and I'm going to make these units cancel out. So teraliters need to be on the bottom, and then liters will be on the top. So teraliters on the bottom, liters on the top. Now the 10 to the 12 goes with the liters. Because I wrote it here, when I do this part, I don't have to do any hard thinking. It's already there. Now, there's got to be a nice, easy way of keeping up with this. Well, what I tell myself is the prefix down here always goes opposite the exponent. So the prefix goes opposite the exponent. So when I look at this visually, I can right away tell, hey, this is right. Whereas if somebody comes in and they write, and they have something like this, they might not immediately recognize that something's wrong, all right? But because I can look at this and say, hey, this exponent and this prefix should be opposite, always opposite, then I'll quickly tell, hey, they've got a mistake here, all right?